Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2011. So let's get started. First problem, a cell phone plan costs $20 each month, plus 5 cents per text message sent, plus 10 cents for each minute used over 30 hours. In January, Juan, like that's how you read it, right? Sent 100 text messages and talked for 30.5 hours. How much did he have to pay? So he has the base fee, $20, plus 5 cents per text message, but he sent 100, so 500 cents. So this would be $5. $5 plus 30.5 hours means 30 hours plus 30 minutes. So 30 minutes times 10 cents would be 300 cents. So this is $3, right? So this is 3. This is 28. The answer is D. Second one, a small bottle of shampoo can hold 35 milliliters of shampoo, whereas a large bottle can hold 500 milliliters of shampoo. Jasmine wants to buy the minimum number of small bottles necessary to completely fill a large bottle. How many bottles must she buy? 500 divided by 35. This is 1 and 35. 150. So this would be 4. And this would be 120. So it got 30 left, and so to fill this leftover 30, we need one more bottle. So 14 plus 1 equals 15. The answer is E. Number 3, suppose AB denotes the average of AB and ABC denotes the average of AB and C. What is the 1100110? So for this one, this could be the average of all these three things. So this will be 2 over 3. Yeah, and so this is 2 over 3, and then 0, 1, this is 1 over 2, so this is a half, and then it's 0, so this will be 2 over 3 plus 1 over 2 plus 0 over 3, this is 3 under 6, 4 plus 3, so it's 7, this is 7 over 18, the answer is D. Number 4, let x and y be the following sums of arithmetic sequences. What is the value of y minus x? Okay, then this would be this whole thing, right? So these two cancel, cancel all the way to 100. So 102 minus 10 equals 92. So the answer is A. Number 5, at an elementary school, the students in 3rd grade, 4th grade, and 5th grade run at an average of 12, 15, and 10 minutes per day respectively. There are twice as many 3rd graders as 4th graders and twice as many 4th graders as 5th graders. Okay, so based on this information, let's say that if there is one 5th grader, then there's twice as many 4th graders, right? So there are 2 4th graders, and so there are twice as many 3rd graders as 4th graders, so there's 4 3rd graders. What is the average number of minutes run per day by these students? Okay, so the total is 7, right? So total is 7 under, and then 4 times 12, 48, 2 times 15, 30, 1 times 10, 10. This would be 88 over 7. The answer is C. Number 6, set A has 20 elements and set B has 15 elements. What is the smallest possible number of elements in A U B? The union of A and B. So the union of A and B. So the union of A and B means both A and B together. So if you don't get what I mean, then to show in a Venn diagram form, it's like this. If there's A and B, this whole thing would be the union of A and B. So the union, and so for there to be the smallest possible number of elements, with A has 20 and B has 15, since B has less than A, then the smallest possible number of elements must be if A is like this and then B is totally inside it, then the sum then the smallest possible number of elements will be just the number of elements in A, which will be 20. The answer is C. Problem number 7, which of the following equations does not have a solution? Okay, so for this one, x could be minus 7, and for this one, oh yes, so this needs to be, so this needs the absolute value of minus 3x to be minus 5, but the absolute value is always 0 or positive, right? So it can't be a negative, so B does not have a solution. The answer is B. Number 8, last summer 30% of the birds living in Town Lake were geese, 25% were swans, 10% were herons, and 35% were ducks. What percent of the birds that were not swans were geese? Okay, so 25% were swans, so not swans were 75%, were geese, so 30% was geese, So 75% under 30%. So if we divide both by 3, then it's 10 over 25. If we multiply top and bottom by 4, it's 40 out of 100. So this is 40%. The answer is C. Number 9, a rectangular region is bounded by the graphs of the equations y equals a, y equals minus b, x equals minus c, and x equals d, where a, b, c, and d are all positive numbers. Which of the following represents the area of this region? Okay, so let's say that there is a region like this, and then a minus b minus c and d would be x is minus c, this would be minus c, this would be d, and this would be minus b, this would be a, and so our rectangle would be drawn kind of like this. No, not like that, like this. This would be our rectangle, and so this would be a plus b, and this would be c plus d, right? And so what we're trying to know is a plus b times c plus d. This is supposed to be b. This is ac plus bc plus AD plus BD, right? And so which of the following represents the area of this region? This is just all of them added together. So this is A. The answer is A. Number 10, a majority of the 30 students in misdemeanors class, misdemeanor. So it says majority, so that has to be over 15. Bought pencils at the school bookstore. Each of these students bought the same number of pencils, and this number was greater than 1. The cost of a pencil in cents was greater than the number of pencils each student bought, and the total cost of all the pencils was 17.71. What was the cost of a pencil in cents? Okay. So first thing you notice is 1001 is a multiple of 11, and 770 is also a multiple of 11, so 1771 must be a multiple of 11, right? And so using this information we can dissect 1771, and so if we so let's take out the decimal and just make it sense. 1771, and then if we dissect it into 11, then this would be 1, and then 161, and then this is divisible by 3. No, not 3. This is divisible by 7. So this is 7, 2. Yes. 7, 2, 3. So this is 7 times 11 times 23, and the only number here that is over 15 is 23. That means that the number of students is 25. That the number of students is 23. So this is the number of students. And the cost of a pencil in cents was greater than the number of pencils each student bought. Okay, so the cost was greater than the number. So since 11 is greater than 7, this is the cost of a pencil. And so the answer is 11 cents. The answer is B. Problem number 11. Square EFGH has one vertex on each side of square ABCD. Point E is on AB with AE equals 7. AE equals 7 times EB. What is the ratio of the area of EFGH to the area of ABCD? And so this is EFGH has one vertex on each side of square ABCD. If this is ABCD, and E is on AB, right? So this is E. So FGH. And AE is 7 times EB, so this would be 7 to 1. And this would be 7, 1, 7, 1, 7, 1, right? And so the ratio of the area of EFGH to the area of ABCD. So if this is just 7 and this is just 1, then whole ABCD would be 8 squared, which is 64. 64. And EFGH, this would be, since this is a right triangle, we can use the Pythagorean theorem, so this becomes root 50, which is 5 root 2, right? This is a 5 root 2, and so this is 5 root 2 squared. This is 50, so the answer is 50 over 64. It's 25 over 32, so the answer is B. Number 12, the players on a basketball team made some 3-point shots, some 2-point shots, and some 1-point free throws. So let's say they made A 3-point shots, B 2-point shots, and C free throws. They scored as many points with 2-point shots as with 3-point shots. Okay, so this tells me that 3A equals 2B, and the number of successful free throws was one more than their number of successful 2-point shots. So C equals B plus 1. The team's total score was 61 points. 3a plus 2b plus c equals 61. How many free throws did they make? So this is asking for c, right? And so if we just plug these in and make it all about b, 2b plus 2b plus b plus 1 equals 61. So b equals 60 over 5, which is 12. And so c equals b plus 1 equals 13. The answer is A. Number 13, how many even integers are there between 200 and 700 whose digits are all different and come from the set 1, 2, 5, 7, 8, 9? Okay, so this can only mean that the hundredths digit can be 2 something and 5 something, but since it has to be even integer, then the last digit would also be chosen for you. And since 2 is already chosen, we only have 8 left. 2 something 8, and then since 5 has both 2 and 8, it could be 5 something 2 or 5 something 8, right? And so since there are 6 possible values, but we've used 2 of them, and so 4 are left. Same here, 4 are left, 4 are left. So the sum is 12. So the answer is A. Number 14, a pair of standard 6-sided fair dice is rolled once. The sum of the numbers rolled determines the diameter of a circle, where is the probability that the numerical value of the area of the circle is less than the numerical value of the circle's circumference. Okay, so the pair of the standard 6-sided fair dice is rolled once. So the sum of the numbers is the diameter of the circle, right? This is 2r. And the numerical value of the area of the circle, this would be pi r squared, is less than the value of the circle's circumference, so 2 pi r. So r would be less than 2, right? But then what we get is the diameter of the circle. So diameter is 2r, so 2r has to be less than 4. So diameter, this can be either 2 or 3, and it can't be 1 because the lowest sum of the numbers rolled can only be 2, and it's 1 and 1, right? And so this could, and this can only be when the numbers are 1 and 1, 1 and 2, or 2 and 1. So the whole thing is 3 chances over 6 squared. So this is 36. This is 1 over 12. The answer is B. Number 15, Roy bought a new battery gasoline hybrid car. On a trip, the car ran exclusively on its battery for the first 40 miles, then ran exclusively on gasoline for the rest of the trip, using gasoline at a rate of 0.02 gallons per mile. So this means that it went 50 miles per gallon. On the whole trip, he averaged 55 miles per gallon. Okay, so he means that. So this means that he went 5 miles more for each gallon that he used. And so since he went 40 miles more, for how many gallons? For, this is times 8, right? So this is 1 times 8, so this is for 8 gallons. And so the whole trip, since he averaged 55 miles per gallon, was 55 times 8 equals 440. The answer is 440 miles. The answer is C. Number 16, which of the following is equal to root 9 minus 6 root 2 plus root 9 plus 6 root 2? If we just square this, then this would be, this squared would equal 9 minus 6 root 2 plus 9 plus 6 root 2, and then plus 2, and then root 9 minus 6 root 2, root 9 plus 6 root 2. This equals, these are gone, this is 18. 18 plus 2 times 9 minus 6 root 2, 9 plus 6 root 2. This would be 2 times root, and then you multiply these together. These would be 9 squared minus 6 root 2 squared. This is 18 plus 2 times 81 minus 36 times 2. This is 72. This is 18 plus 2 root 9. This is 18 plus 6 equals 24. So this is, and so if you take the root of this whole thing, then it's root 24, which equals 2 root 6. The answer is B. The problem 17, in the 8-term sequence A, B, C, D, E, F, G, the value of C is 5, and the sum of any 3 consecutive terms is 30. Okay, so if C is 5, then a plus h, right? If a is a, then b would be 25 minus a, then this would be a, since these three have to add up to 30, these three have to add up to 30, so e is 25 minus a. F is 5, since these three have to add up, and so this is a, this is 25 minus a, so a plus h is a plus 25 minus a, which is 25. The answer is C. Number 18, A, B, C each have radius 1. A and B share one point of tangency. So let's say there's a circle, and then we have another same circle, like this, and they share 1 point of tangency. This is A, this is B. Circle C has a point of tangency with a midpoint of AB. So the point of tangency would be like this, since that's the midpoint of AB. So this would be circle C. This would be the midpoint of AB. Where's the area inside circle C but outside circle A and circle B? So what we want is this area right here until right here, right? But then what we see is we can make this a straight line, I said, and then we can split these two, and then we can separate this to become part like this, and this to become a part like this, right? And so this would come here, and this would come here, right? And so the area is going to be just the area of this rectangle right here. And since the radius is 1, this is 1, this is 1 plus 1 is 2, and so 1 times 2 equals 2. The answer is C. 19. In 1991, the population of a town was a perfect square. 10 years later, after an increase of 150 people, the population was 9 more than a perfect square. Now, in 2011, with an increase of another 150 people, the population is once again a perfect square. Which of the following is closest to the percent growth of the town's population during this 20-year period? Okay, so let's say the population was a perfect square, so let's say the population was x squared, and then 10 years later, the population was 9 more than a perfect square, right? So x squared plus 150 was 9 more than a perfect square, so let's say that this perfect square is y squared. Then if we move the 9 over, then this will be 141. This equals y squared, so 141 equals y squared minus x squared. This is y plus x, y minus x, and so this would be, if we split 141, this can split into 3 and 3, 4, 7, so 47 times 3, and so this would be 47, this would be 3, and so y would be 25, x would be 22, and so the percent growth of the town's population during this 20-year period, this means that, so since x is 22, so x squared, this is 484, and the growth is 150 people and another 150 people, so growth is 300, and so what we have to get is 300 over 484. This is 3 times 25, so it's 75 over 121, and so let's get that, right? 75 divided by 121 would be 0. And then let's put a 0, 6, 1, 2, 6, no, not 1, 7, 2, 6, and then 24, and so we have a 161 point, so this is 121, this is 119, so this would be 9, 9 times 9, 18, and so this will go like 0.619, which is closest to 0.62, so this is 62%. The answer is E. Okay, so problem number 20. 2 points on the circumference of a circle of radius r are selected independently and at random. From each point, a chord of length r is drawn in a clockwise direction. What is the probability that the two chords intersect? So let's draw the circumference. So the circle is like this, and then we have the radius r like that. So this would be r, and then 2 points are like this. So let's say that this is the point and this is the point, and this would also be length r, right? From each point, a chord of length r is drawn in a clockwise direction, so it will be like this. And this for this it will be like that. Let's make it straight. Yeah, like that. And so, what is the probability that the two chords intersect? So what we want is for this and this to intersect, right? But then, first let's say that this is fixed. So that's a fixed point that doesn't move. And let's only say that, and let's say that only this can move. And so, yeah, the chord itself is this, right? So this is constant, and this can move. This can move, and so so the way that that the chord could like intersect this blue line would be for it to be like this, so that this is here and this is here, right? So this would be 60 degrees, and yeah, and the other way is for this to be like that, right? So it works for every single angle from, this is 60 degrees. So it works for every single like angle that's from here to here. So this intersects, this intersects, this intersects, this intersects, everything. Like this intersects, this intersects, this intersects, everything until this point where this point intersects. So the degree measure is 120 degrees. So it's 120 degrees over the total is 360 degrees. This is 1/3. The answer is D. Problem number 21. Two counterfeit coins of equal weight are mixed with 8 identical genuine coins. The weight of each of the counterfeit coins is different from the weight of each of the genuine coins. A pair of coins is selected at random without replacement from the 10 coins. A second pair is selected at random without replacement from the remaining 8 coins. The combined weight of the first pair is equal to the combined weight of the second pair. What is the probability that all 4 selected coins are genuine? Okay, so let's say, so we have the two possibilities. The first is that it's genuine, and genuine. That's what we're choosing. And the second is that we're choosing genuine counterfeit and genuine counterfeit. So for this to happen, the first one, this would be 8 choose 2. This would be 6 choose 2. And so this would be 8 times 7 over 2 multiplied by 6 times 5 over 2. This is these two, and this becomes 2. So this is 12 times 7 times 5. And then this would be 8 because there are 8 ways to choose a genuine, and then 2 because there are 2 ways to choose a counterfeit. And this would be 7 because 7 ways to choose a genuine and 1 way to choose a counterfeit. This would be 8 times 2 times 7. And so what we want is, this is 12 times 7 times 5. So 12 times 7 times 5 over 12 times 7. This is multiplied by 12 times 7 times 5 plus 8 times 2 times 7. So let's divide by 7 and by 4. So this will be 3, this will be 3, and this will be 2. So this will be 3 times 5, this is 15. 3 times 5, 15, plus 2 times 2, 8. No, not 8. 2 times 2 is 4. So this would be 15 over 19. The answer is D. Number 22. Each vertex of convex pentagon A, B, C, D, E is to be assigned a color. There are 6 colors to choose from, and the ends of each diagonal must have different colors. How many different colors are possible? Okay, so there's a pentagon A, B, C, D, E, but then the diagonal must have different colors, right? So what's important are the diagonals, and the diagonals are like these. So these almost have like different colors. And so let's discard the outward things, and let's just focus on this star-shaped thing. So so the first thing that you can think of is that all the colors are different. So this would be color A, B, C, D, and E. But then that's not the only way, because it just said that the ends of each diagonal must have different colors, and it didn't say anything about the points that are next to each other, right? So it could be A, B, C, D, and this would still have all the diagonals different from each other, and we could also have an A, B, B, C, and it would still be different, right? And obviously we can't have an A, B, B, C, C, right? This should be a B. It doesn't matter anyway. But how many different colorings are possible? So for this one, so it's labeled A, B, C, D, E, right? So this is just 5 factorial ways. No, there are 6 colors to choose from, right? So this is 6 times 5 times 4 times 3 times 2 ways. For this, we have 2 that are the same colors, so we can choose like the configuration of the same colors. So would the same colors be here? Would they be here? Would they be here? Would they be here? Or would they be here? So that's 5 choices. 5 choices, and then we're choosing 4 colors, right? So 6 times 5 times 4 times 3, that would be the 4 colors. And for this one, we have and so we're also choosing where to put this single color. So we could put it here, or here, or here, or here, or here. So we have 5 choices for that, and then we have 3 choices for the colors. 6 times 5 times 4. And so if we all add these together, it would be this plus this equals, okay, so let's take out the 654, 654, 654, 654. 6 times 5 times 4 times, and then 3 times 2. 6 plus 5 times 3, which is 15, plus this is just 5. So this is 20 times 6, so it's 120 times 6 plus 15 plus 5, this is 26. This is 26 times 12, this is 2, 12, 4, 26. No, this is not 4. 62, 42. There's no 4 here, and this would be 52. Multiply, and then 260. This would be 310. No, 312. So it would be 3,120. The answer is C. Number 23. 7 students count from 1 to 1,000 as follows. Alice says all the numbers except she skips the middle number in each consecutive group of 3 numbers. That is, Alice says 1, 3, 4, 6, 7, 9, all the way to 997, 999, 1,000. Barbara says all the numbers that Alice doesn't say, except she also skips the middle number. Candace says all the numbers that Barbara and Alice doesn't. That neither Alice nor Barbara says. She also skips the middle number, so it gets smaller every time. Debbie, Eliza, and Fatima, they are all like the same thing. And finally, George says the only number that no one else says. Okay, so let's make this a bit smaller since it looks like it's really big right now. So Alice, Alice would say 1, 3, 4, 7, no, 1, 3, 4, 6, 7, 9. And so let's focus on what Alice doesn't say, because that is what the next person is saying, right? And so Alice doesn't say 2, 5, 8, 9, 10, 11, 13, 16. And then so, yeah. And so Alice doesn't say, and then Barbara doesn't say the second numbers like this. No, 2, 5, 8, and then 10, 13, 16, those kinds of numbers. So yeah, let's put this bigger. Alice says, so Alice doesn't say 2, 5, 8, 8, 11, 14, yeah. 2, 5, 8, 11, 14, 17, 20, 23, 26, 29, 32, all the way. And then Barbara doesn't say this, no, this, 14, 23, 32. So this would be 5, 14, 23, 32. And then if we can continue the pattern, this would be, this is adding 9 each time, right? So this is 41. And then, yeah, and then C, yeah, and so Candace would not say this one and this one, so this will be like 14, 41. And so if we put these into like equations with like until the nth term, then the nth term would be 3n minus 1. The nth term of this would be 9n, 9n plus, no, 9n minus 4. And the nth term of this would be 27n, right? 27n minus 13. And what we see, and what we begin to see here is that this 4 is the sum of 3 and 1. 13 is the sum of 9 and 4. And we also see that 3, 9, 27, it's getting bigger and bigger by like, what do you call it? By the exponents? No, not the exponents. So by the 3 to the nth powers, right? You know what I mean. Sorry, I forgot the word for it. And so anyways, the next one will be 27 times 3, right? This would be 81, and minus, and then 27 plus 13, this would be 34. No, this would be 40. So this would be D not saying, and then E won't say 243n minus 121. F won't say 700, 729n minus 364. And so this is what George would say, right? And so George would say 729n minus 364, but then n has to be 1, since it's 1 to 1,000, so the limit is 1,000. And so if n is 1, then 729 minus 364 equals 365. So the answer is C. 24. Two distinct regular tetrahedra all have their vertices among the vertices of the same unit cube. What is the volume of the region formed by the intersection of the tetrahedra? Okay, so let me try to graph this. No, not graph. Let me try to draw this as bad as my drawing skills are. And so, if I just shade, like, put in the bits that are the triangle, then it's this part, if you can see it. These parts right here, they're all like part of the triangle. So it will be this part and this part. And so it will be like that. Okay, like this, and then it will be like that. So let's try to erase. Then it would be something like, oops, erase. And so it would basically be something similar to this, right? I don't know if you see it. I really hope you do. But then we can see that this shape has their vertices in the same unit cube, which is this one right here. And so since and so first we have to notice that the intersection of the tetrahedra, so the intersection is basically this. I don't know if you can see it here, but it's basically this giant tetrahedron that this is big tetrahedron minus 4 of these smaller tetrahedrons, right? And so minus 4 of the smaller tetrahedrons. But then what we notice is that minus 4 of the smaller tetrahedrons. But then what we can notice is that this side length of the big tetrahedron is twice the side length of the small tetrahedron, right? And so the volume ratio of the big tetrahedron to the small tetrahedron will be 2 cubed to 1 cubed. So this is 8 to 1, right? But then if we have 4 small, then this would be 4 times 4, this would be times 4, this would be 8 to 4, this would be 1 to 2. And so the 4 small tetrahedrons are 1/2 of the volume of the big tetrahedron. And so what we actually need is is half the volume of the big tetrahedron, right? So now we know that we need half the volume of the big tetrahedron, and so we can just find out the volume of that one tetrahedron, and then we'll be done, right? Since this is 1, and this is 90 degrees, this is a 45 degrees, and so we know that this is root 2, and then so since that length is root 2, let's draw another small tetrahedron here. Yeah, since this is root 2, and we have the center of this, we can align it like that, and then that's root 2, this is root 2, this whole thing is root 2, and so the base, and so the distance from the middle will be root 2 over 2, and so if we just see the base right here, then if the base is like this, then the base would be, this is root 2, this is root 2 over 2, and so this would be root 6 over 2, right? And so this is root 6 over 2, base is root 6 over 2 times root 2 times 1/2, and then this multiplied by this height, right? And so we need to find this height, but then first we need this length, and then this length is 2/3 of the height. So this is 2/3 times root 6 over 2, and so this is and so this equals, this cancel out, so this is root 6 over 3, and so this is root 6 over 3. So this one becomes, let's say it's this triangle, so that triangle is now, this is root 2, this is root 6 over 3, and so this becomes, this is 3 root 2 and root 6, so this would be 18, 6, this would be root 12 divided by 3, and so this will be 2 root 3 over 3, so this will be 2 root 3 over 3, and then since it's a pyramid, this would be times 1/3, and then we need to do this 1/2, and so this should be a bit smaller, yeah. And so if we try to compute this whole thing, then what we get is first 2 cancel, and then root 6, root 2, and root 3, they combine to make a 6, which is then divided by 2 and 3, and so this would be 1 over 6. So the answer is D. Last problem, problem number 25. Let R be a square region and n is greater than or equal to 4, an integer. A point x in the interior of R is called n ray partitional if there are n rays emanating from x that divide R into n triangles of equal area. How many points are 100 ray partitional but not 60 ray partitional? Okay, so let's see. R is the square region, like that, and then n is greater than or equal to 4. A point x in the interior of R, let's see that this is point x, it's called n ray partitional if there are n rays emanating from x like this, that divide R into n triangles of equal area. How many points are 100 ray partitional but not 60 ray partitional? Okay, so the first thing that you need to know is that this has to be touching this vertice, this corner, right? Because if it doesn't touch it, then it would be like this, and this would be a quadrilateral, and so so that wouldn't be a triangle. So that's it, right? And so we know, and so we now know that this has to be touching these 4 vertices, like so, like that, and like this. Let's make these a little bit straighter too, like that, like that. Yes, and so. Let's say that this is a unit square. Then this would be 1, right? This would be 1. This would also be 1. And then let's say that if this is 100 repartitional, and then we know that the red area is equal to the blue area, right? And so the red area is equal to the blue area, and if you're asking why, then let's divide this up into 4. Let's divide this into more areas. So we see that this blue area is the same as this red area. This blue area is the same as this red area. This blue area is the same as this red area, and this blue area is the same as this red area. That means the ratio of blue to red, blue to red, blue to red, blue to red is all 1 to 1, and so we can say that the red ratio is equal to the blue ratio. And then let's just say that there are, I don't know, a triangles in this. And so if there are 8 triangles, then since this is 1, and the total area would be A over 100, right? Since each triangle has 1 over 100 area, and so the area would be A over 100, and so this height of the triangle would be A over 50, right? And then the same thing with this triangle here. Let's say that there are B triangles in this one, and then so the area of this would be B over 100 because of the same reason, and so this would be B over 50, right? And so we can say that, and so this is when it's 100 repartitional, right? So if it's n repartitional, then we can see that the point x is of a form of A over 50 is half of 100, right? So this is n divided by 2, comma, divided by 2, comma, B over n divided by 2, and A and B are all less than n over 2. And so if it's 100 repartitional, then there are 49 possible A's and 49 B's, 49 possible B's. So so there are 49 squared number of points that can be 100 repartitional. And if it wants to be 60 repartitional, then it would be A over 30, comma, B over 30, right? But then what we need to know is, but not 60 repartitional, so what we need to do is take the 100 repartitional and subtract the number of things that are 20 repartitional, not 60 repartitional, because we need the greatest common divisor of both 100 and 60. So that would be the intersection of the 100 ray and 60 ray, right? And so this can't be 30, but since it has to be a 20 repartitional that's subtracted, this would not be 30, and this would instead be 10 and 10. And so since there are 9 A's and 9 B's, so this would be 9 squared number that has to be subtracted. And so what we need is this and this. So we've got them. 49 squared minus 9 squared equals 49 minus 9 times 49 plus 9. This is 40 times 58, right? And so this is 40 times 58. This is 58 times 4, 32, 2, so it's 232. So it's 2320. So it's 2320. The answer is C. And that was problem number 25, and thank you for watching.